The next one is soil composition. How many of you guys have noticed that in a lot of farm fields out in our area, that when it rains heavy, they start developing a lake in the middle of the field? You guys noticed that before? Okay. Well, there's a lot of reasons for that. And you might think to yourself, okay, now how is that possible? You've got a farmer out there tilling up the land all the time. Should easily allow water to seep into the ground.
And kill all of his.
Well, it could.
Was it 2 years ago? It happens like every year, but there's a farm right down the road from my house where the guy normally loses half of his crops on each of his fields because when it floods, they're right next to big hills.
Yep.
And when it floods, it
Well,
destroys everything.
Yeah. I mean, basically the concept on this is that we have a lot of different soil types. This is one of the things that we're going to look at throughout this unit. Well, one of the things that's kind of important is we look at clay versus sand. Remember we did this with the stones? We had sandstone. I had you guys pull out the shale. What did you know about the sandstone versus the shale? When you put water on the sandstone, what did it do? It soaked it up really easy. Put it on the shale, what happened? It ran off. That's because shale is made out of clay. Clay is impermeable. We'll write that word out. Impermeable. What does that mean? Yeah, you can't get through it, okay? It's not able to be permeated, it's not able to be infiltrated, so it's impermeable. That means the water can't seep into the ground, so it just sits on top. There's a lot of areas that have clay soils, which since we're so far south of the glaciers, this is where we get a lot of our clay depositions is all over our entire area. So it actually becomes quite an issue with trying to let that water seep into the ground, which is why most of your basements flood. Because that water's not able to drain below your basement. The clay keeps it within 10 feet of the ground. So we have a very low water table. Well, the other thing I want you to notice is the image itself. What do you notice about A versus B? Which one's going to allow water in? Why? They're farther apart. There's some holes in there, right? Okay? Just stop it. 30 seconds. Which region of the United States would you expect to have the lowest dangers of flooding? Arizona. What do you think, Brandon? General regions.
At least likely to flood?
Yeah.
Places where the soil is like somewhere that it like rains a lot.
Texas. Very good.
China?
Within the United States.
Yeah.
Arizona. Why do you say Arizona?
Because there's a lot of deserts on them, and the deserts are full of sand. It's
Okay.
loose, so it's like the ocean sink in them.
Does it full of sand?
Yeah.
Doesn't really rain that much. However, it's actually quite mountainous in the southwest. Texas is kind of an interesting one.
Washington.
Washington State or Washington, D.C. Yeah, Washington State actually has pretty low flooding issues. Actually, the desert regions have one of the worst flooding issues. They really do.
We were talking about this yesterday. You could just know, like, the ground won't absorb the water, so there's nowhere for it to go.
Yeah, normally we have this very loose soil, so the water is very easily able to permeate that layer and kind of snake its way inside the soils, which is why after about an hour of rain, most of our soils around here, they're wet, they're moist, but you don't have standing water. And most of the desert regions, that top layer is so compacted that the water simply cannot seep into the soil more than just a few inches. So all that rain comes in and just runs off. And within a day or two of having a good storm, we now have raging rivers where we used to have dry riverbeds. It's kind of crazy, actually. In fact, when I lived down in Arizona, I was quite thrilled to hear this, and I just love the title. They passed what they call the stupid motorist law. For those guys who like to be adventurous and like to go out mudding, take your four-wheelers, go out there and be crazy. Well, these dry riverbeds, for the most part, never have anything in it, and they're nice, and they're pretty deep. They're 20, 30 feet deep. And so people will take their trucks and then go drive down through these little valleys, down inside the dry riverbeds, and then the water shows up after a rainy day. And it doesn't just show up. It really is a flash flood. You wouldn't think about that. I mean, we think about flash floods like in these nice little narrow canyons. But these flash floods, I mean, no, the water will literally show up in less than an hour. Also, you'll start seeing a little trickle of water, and then before you know it, you're surrounded by water. And it was happening enough where these people would go out and they're like, I can cross that road. That water doesn't look too deep. Keep this in mind. 6 inches of water on a 3% downgrade. So that's about, right about that. Just enough for water to be moving. 6 inches is enough to move a parked vehicle. So you think about water, and you think about driving through the flooded road, that's a really bad idea. Really bad idea. So I can't tell you how many times our fire department and police departments were sent out to go rescue these idiots and decided to drive through standing water. And so they finally passed this concept called the stupid motorist law. If you're stupid enough to go driving through it, you will pay us back for rescuing you. And that's how they do it. I think it's perfect. It's a stupid motorist law. Hello, the road's flooded. Don't go through it. Oh, I can do it. My truck can do that. Help me. It's kind of funny. All right. One of the other effects is slope. And with that, I'm going to pause the notes for a little bit because I want to make sure we do this demo. This is that low slopes have little runoff but high infiltration. High slopes have rapid runoff with very little infiltration. Okay, so when we think about what are those factors that affect runoff, we've got vegetation, composition of the soils, rate of precipitation, and the slope of the hill. All those four things work together to determine how much runoff we really have. And one of the last things I want to talk about are stream systems. How many guys have heard of a watershed before? And what is it? Well, guys, a watershed is nothing more than basically all the area that drains into a given river. So, for example, if you look at this image, this is the St. Joe River watershed. So the little outline that you see here is all the area in the land that drains into the St. Joe River. Where are some of the towns that you recognize on here?
Auburn, Garrett, Fort Wayne, Butler.
Yeah. So what's important about that is understanding that what's happening in these cities affects the St. Joe River. Because eventually whatever's going on in those cities will get into the groundwater or it gets into the surface water, as in the small creeks or drainage ditches, and all those will eventually will find their way to the St. Joe River. So when you think about it, if I have a gas station out here in the middle of nowhere, so I got a little gas station out here, you're not thinking much, okay, it's not really that big of a deal, it's just a gas station. it's got a very slow leak out of its gas tanks underneath the ground. Will that affect the St. Joe River?
Yeah.
Yeah, and it honestly does. I'm not sure if it does it to a point where we need to, raise local concern about it, but it will most certainly affect the St. Joe River. So when we think about dumping things in your backyard, dumping things somewhere, think about all this stuff eventually will lead into the St. Joe River. Which is why some of the bigger rivers aren't exactly the most fresh-smelling rivers. Earlier today we talked about the fact that the faster water is moving, the more it can carry. And we'll talk about more about this as we get to stream development on Thursday and Friday. But this is kind of what I really want to talk to you guys here about some basic terms. Stream load. We'll talk about stream load. It's all the material that the water can carry. Or basically it's all the stuff that the water can move. Total weight of material that the water can move. It's called the stream load. If you're in some of the worst areas of the United States, that might include cars, bikes, bodies, tires, especially from flood, we carry a lot of bodies down that river. I'm not kidding. I seriously do.
What river?
The Flint River in Michigan. Flint, one of the murder capitals in the United States. They pull at least 3 or 4 dead bodies out of that river every single year. Not because they drown, because it's a convenient place to put them.
I got a delivery to make.
So with like the stream load, would that kind of go with like how water slides are partly manufactured, because the only way they can move a certain amount of weight is like the pressure behind the water?
Yes. Alright, Zach, Brandon. And when we think about the stream load, there's 2 ways that the water carries the material. It either carries it in suspension, or it carries it as bed load. What does it mean to be held in suspension? Floating. That's pretty much it. Whether it's floating on top of the water or floating somewhere within the water column. So every single one of these specs is in suspension. It's floating in that column. It's kind of like if you were to take a jar and put it down the middle of the water column, all the dirt that gets collected inside that water, those are all the materials that are being held in suspension. Over time, those things will filter back out. Bed load, on the other hand, is all the stuff on the bottom that gets rolled around. Too heavy to be floating, but still light enough to be moved by the river.
Like shells, like in a lake, like all the stuff like sits on the sand, but it doesn't sink in.
Well, it's all stuff that moves within the water. Still has to move, not just sitting there. It has to be moving. So when we look at this, I want to go ahead and play this for you guys here. One of the things, again, we look at suspension, and it's all the stuff flowing down the river, held in suspension. But what do you notice about the particle sizes? About what's floating versus what's rolling? Bigger? Yeah, something that's held in suspension is pretty small pieces. The larger pieces are being rolled down the stream bed. If you look here, this guy right here is not even moving, and at least he does a little bit, then he just stops, right? So the bigger you are, the more energy it takes to move. That energy comes from the velocity of the water. So when we think about this, this is what we call carrying capacity. Write this down. Carrying capacity. Best way to define this term and what it means is that the faster water is moving, the larger and more material the water can carry.